6 of your student journal. Today we're going to be, need your attention back up here. Today we're going to be talking about perpendicular and angle bisectors. I want you to read through page 166 on your own, just really quick, making any notes you need about those two theorems right there. Okay? Kind of make any notes, write them out in your own words if you have to. Any clarifying terms there. Okay, on those two theorems, I want you to tell your neighbor what they both mean. You have to use your own words. Explain what they mean in your own words to your neighbor. Question, please. So, 6.1. Notice 6.2 is the converse of this. So they're just switching your hypothesis and conclusion, if you remember back. It's a good thing to remember since we have our final coming up. But in a plane, if a point lies on a perpendicular bisector of a segment, then it's equidistant from the endpoint. So, if a point lies on a line that is the perpendicular bisector, notice how we know it's perpendicular bisector. We have the right angle marking. We have these lines saying, hey, it cuts it in half. So the right angle is the perpendicular piece. These markings showing that it cuts the line in half is the bisector piece. Okay, so make sure you have that down. Okay, if a point lies on it, then it's equidistant from the endpoints A and B. So that means any point on this line is going to be the same distance away from A to B. So if I put a point here, same distance from B as it is to A. And then if I put a point here, this distance is going to be the same to each of those. Just like point C here, that makes this distance the same as that distance. What type of triangle is that then? Not an equilateral. It is. This is an isosceles triangle. Okay? Two sides are equal. Isosceles. Now my markings are getting kind of messed up there. Too much drawing. There we go. Okay. Very good. And this just the converse says, hey, if a point is equidistant, then it lies on the perpendicular bisector. That means which point lies on this perpendicular bisector? Well, P does, for sure, because it's on there. What else? C. Well, it's on there as well. What other point's going to lie on that perpendicular bisector? D. Yeah. D will. Okay, D will because it's equidistant from here to there. Okay? All right. Yes?
Why do we say equidistant instead of
Equidistant or equidistance? All right. Hey, take a look at the next page, page 167. I want you to read those two theorems and then explain them to your neighbors. Okay. Okay, have your attention back up here. Theorem 6.3, if a point lies on the bisector of an angle, remember that means it cuts it in half. That means this is congruent to that, those markings there. Then it's equidistant from the sides of the angle. So notice point D is equidistant from AB as it is from AC. However, the little caveat here they don't talk about is that this distance has to be drawn at a right angle to that side length. Okay, and it has to be drawn at a right angle to that side length as well. So it has to go from that angle bisector and hit at a right angle on both. Okay, and then you have the converse of that. If this is equidistant, then the point lies on the angle bisector. Okay, any questions there? 4 quick theorems, and there's some online, if you wanted to go to the Clever website and try some of the online explorations, you could definitely do that. Okay, page 168. I want you to take a look at that. I want you to apply some of these things in or on this page here, 1 through 7. Off you go. Okay, here we go. Should be done with numbers 1 through 3. Okay, number 1. AB is the same length as AC because it lies on the perpendicular bisector, point A does. Therefore, this is 9. We know this is perpendicular bisector because we have the right angle and we have equal sides here. Okay, number 2, we've got our perpendicular bisector. Okay, we have perpendicular. We know that these distances are equal from the endpoints to a point on that line. Therefore, this is perpendicular bisector, which means it cuts this EG in half, meaning this length right here, 3, is the same as this length right here. So that's 3 as well. EG then gives us a total of 6. So make sure you don't find just this. You have to find the entire length there. Okay, and then the last one, SU, is that a perpendicular bisector? Is RU a perpendicular bisector? Yes? Tell your neighbor how you know. That's not a good reason. Okay, there is a right angle. That means it's a perpendicular line. How do we know it bisects? Yeah? Go ahead, Isaac. Yeah, RT and RS are congruent. They're both 10. Therefore, they're equidistant from the endpoints. Good. Which means this and this then are also congruent. Well done. So 3x equals 2x plus 12. Or 2x plus 2, excuse me. So 1x is 2. And if I'm trying to find SU then, I've got to plug that 2 back in right here, which gives me 4 plus 2 or 6. Cool. Any questions? All right. Number 4, find the equation of the perpendicular bisector. Good thing we talked about slope and perpendicular lines today. Dude.
Oh, you're supposed to be doing this right now?
If I'm doing the equation of a line, what's the new slope going to be? Hey, what's the slope of this line? Yeah, it's 2, up 2 over 1. Okay, so current slope is 2. What's our new slope have to be a perpendicular? It has to be the inverse reciprocal. So the perpendicular slope is going to be negative 1/2. Okay? And if it's going to bisect AB, that means this distance is going to be the same, and this just happens to be the midpoint. We know that because if you go up 1 and over, or up 2 and over 1, and then up 2 over 1, okay, you're halfway there. So, from this, we want a slope of negative 1/2. We can go down 1, over 2, up 1, over 2. We can get our line in there. However, it's kind of hard to tell what our Y-intercept is by doing it that way. Okay, how could we find the Y-intercept? Do we know a point on this line? Yeah. Point is right here. What's the coordinate of that? Okay, so write the equation of a line that goes through this point and has that slope. And use point slope form again. It's up to you. You could use point slope, or you can go y equals mx plus b. Okay, y equals negative 1/2 x plus 1. All right. Okay, you got 5 through 7 there. Okay. Okay. Go for it. Yep. You guys, it was pointed out by a couple different people here that I switched these two values when I was plugging them in, which is a big problem when you're calculating this, which we should have been able to note from our picture. So when I do that, this should have been negative 1/2. And then that makes this minus 1/2, which I think, Maddie, that's going to fix how yours didn't match up. Okay? Thank you for pointing that out. Alex, was that what you were going to say too? I appreciate everyone pointing that out. Good job. Following along there. Nice work. Okay. Hey guys, really quick on these. Number 5, what's CAB? Yeah, it's 40. This is 20 because it's on the angle bisector, in the angle bisector. So these are equidistant. Therefore, this is an angle bisector, meaning that is 40 degrees. So your explanation would be talking about point D being on the angle bisector because it's equidistant away from the two legs of the angle. What's DC? 5. Since it's an angle bisector, that is 5. And what is BD? Now, how did we get 4? Good. Those two things have to be equal. All right, which ends up, we move the 1 over, we get 2. Move that over, we get 2x. So x is 1. And if x is 1, we plug that back in for x here. We get 3 plus 1, which is 4. Okay. All right, make sure you're explaining your reasoning. Okay, showing your work and talking about this being an angle bisector because point D is equidistant from the legs of the angle. Okay. All right. Any other questions? Good job today.